So let's discuss about beams. So beam is a horizontal component of any structure. A beam is designed to take up the transverse load. Now when a beam is subjected to different type of load, it basically bends. Now it can bend in two ways. First is sagging and second is hogging. Let's discuss them one by one. First, sagging. So when a beam is sagging, it is going to have a curve like this. So a beam is said to be sag when it is having compression on the top fiber and tension in the bottom fiber. You can talk about stress and strain of compressive and tensile nature on the top and the bottom fibers respectively. Now the second type, which is hogging. So when a beam is subjected to hogging, it bends like this. Here the nature of stress and strain on the top fiber is tensile and in the bottom fiber it's compressive. Now as I've said that there are tensile stress strain and compressive stress strain and on the top and the bottom fiber. But there is a plane where there is no stress and strain. That plane is called as the neutral plane. One very important point related to the neutral plane is that it passes through the centroid of the cross section. Okay, now let's talk about the neutral axis. So if this is a neutral plane, okay, then the intersection of neutral plane and the cross section gives you axis. These axes are called as the neutral axis. Neutral axis is that axis about which the beam is said to be bent. So all the bending moment is being applied about the neutral axis. And as this axis is very prominent, all the important calculations are done with respect to this. With respect to the neutral axis, the distance of any respective fiber is measured. Suppose you are going to calculate stress at this particular point in the beam. Then the distance of this point, or say the plane carrying this point, will be measured from the neutral axis and it is represented by Y. The cross section will be having a certain moment of inertia, which is also calculated with respect to the neutral axis. So that is represented by I. So remember, I is the moment of inertia about the neutral axis. Now, the bending moment acting on the beam is represented by M, which is nothing but the maximum bending moment acting on the beam. Using this formula, you can calculate the maximum bending stress. Maximum bending stress, sigma max, is given by the formula which is called as a flexure formula, written as sigma b is equal to my upon I. And this is very important formula. This also tells us that what is the nature of bending stress. The nature of bending stress is basically linear, as it varies linearly with respect to the distance from the neutral axis. I hope you like all these information, and these information will be useful for your exam preparations. Keep following Acharya Plus. Take care.